Okay, hello guys. How are you doing? That's good. Okay, great tools. Right now we will be focusing on this video. We'll be focusing on inverse functions. So we'll be focusing on a parabola. Okay. So before we get to do this, I would just want to draw. Before we get to inverse function, let me just before we get to parabola. Let me do something like here. I want to draw different types of functions. So let's say we have the following function, the following straight line here, and we have the following function, and okay, so we want to check this thing whether they are functions, whether these things are functions or not. We want to test whether these things are functions or not. So to test whether something is a function or not, we use what we call the vertical line tests. We use the vertical line test to check whether something is a function or not. For example, on this parabola, if I put a line, as long as it cuts, when I put a vertical line, it cuts once, then it means that thing is a function. This is a function. Then this one, when I put it cuts twice, so this one is not a function because of it does not pass the vertical line test. It cuts more than, so if it cuts more than once, and it's not a function. So if I put line here, it tells me this is a function. And then this one is a function because it cuts only once, the graph only once. This one is a function. So it's very important to understand how do we show whether something is a function or not. Okay, cool, that's nice. Okay, now let us go back to inverse functions. So basically, when we're talking about inverse function, so when we're talking about inverse function, before we come here, let's just discuss inverse. So basically, guys, inverse function is the same as saying the reflection about the line y is equals to x. So basically, when we talk about inverse, we're talking about the reflection about the line y is equals to x. So it means it's basically y a change over the x value. So if I have the coordinate 2 and 1, then again this thing has undergone a reflection about, this one has undergone reflection about the line y is equals to x. It means x here change, x nearly 2, good or x, it means the line y is equals to x, it's our mirror. Like good or change y monele good over 1 and 1 and 2. So if I draw my Cartesian plane, like this, 2 and 1, how can I check out 2 and 1? Where's 2 and 1? 2 and 1, x is equals to 2. 2 and 1 m. 2 and 1 level, and then the 1 and 2 you have somewhere 1 and 2. Okay, check again. So if we draw the line y is equals to x like this, this is the line y is equals to x, becomes basically that's the reflection. Basically that's the reflection. This one x is my mirror, so this one is the reflection. So basically that's what we talk when we talk about an inverse. Inverse is also, bear in mind that the inverse is also the reflection about the line. Okay, so still on inverse. So basically what we do is, if a function, we call it f, it means now the inverse of the function, we're going to call it f to the exponent minus 1. This is how we represent an inverse. So inverse is going to be So f is going to change to what? The inverse f minus 1. You know, when it's g of x, it means the inverse is going to be g1 of x. Basically, that's how we find the inverse. That's the inverse, the reflection about the line y is equals to x. Okay, now we're going to start with the inverse of a parabola. Inverse of parabola. I'm not going to touch the inverse of a straight line. Just now we're going to discuss the inverse of a parabola. It's very nice. So now let's we're going to use a very, very simple parabola, the one that we have learned go grade 10. Okay, so let's say we have f of x, which is equals to x squared. We want to sketch this graph. So we know if you're going to draw the graph, it's going to be something like this. It's a smiley face. Because of your a here, it's positive, we know it's a smiley face. And if it's a smiley face, you can just choose any point. If I choose x, for example, if I choose x to be 2, what will be my y? So it means I'm going to substitute the 2 here more x, then y is going to be 4. Okay, so this is the graph. Okay, so now when I find the inverse of the graph, it's very easy. You just take this point, one of the points, 0. So it means when you take the inverse, let me copy this one, is going to be my f. So it means when you take the inverse, what's at this point y change? You have 4 and 2. So if you can check, 4 and 2 is still in the same, is still come. So it's going to be come. So here we're going to have basically 4 and 2. Remember? So this point now graph yaka yo tsamaya. No, you just change one point, this point and this point, 0 over 0 to 0, we change it. Then when you find the inverse, you switch points. Remember the reflection about the line y is equals to x. You remember, no? Okay, so this is what we have. So when I draw a vertical line on the inverse, it cuts twice, you see. So basically when I draw a line on the inverse, it cuts what? Twice. Then it means now the inverse of a parabola is not a function. So since the inverse of this one is not a function, there must be something that we must do, there must be something that we can do so that we can make the inverse to be the function. So the most important, what we're going to do to make this thing a function is when we're going to make this thing a function, we're going to restrict the domain. We restrict the domain in order for this to be a what? To be a function. We restrict the domain. So how restrict the domain? Why to like a domain like the x? So basically when you talk about the domain, we are looking at the what? At the x. So now when we restrict the domain, we have two situations. So let me start with situation 1. Basically situation 1 is when we can write f of x as x squared. Then I restrict the domain, x is greater or equals to 0. I only take one part of the function. So now it means now my graph is going to be something like this. So I take only one side, because when x is equals to 0 is this side level. So I take just one side of the, I get a parabola it's almost so so I only take one side where x is greater than 0. Right? Then I choose that point there, which is going to be 2, which is going to be 2 and 4. Level. Then I'm going to reflect. If I want to, this is the f of x, my f of x. Right? Then I'm going to take this point and reflect it about the line y is equals to x. So Hegi reflect about the line y is equals to x. Hegi reflect about the line y is equals to x. You find this point, which is going to be, so you change y over x, go over 4 and what? And 2, still in the same quadrant level. Go on now, the inverse is going to be something like this. Go to the inverse is going to be like this. And I can draw that. That's the reflection. So now if I put a vertical line on the inverse, now is a function because of it's only one part of the function. So it means if f of x is x squared, then it gets one side where x is greater than 0. It means it's the positive x-axis in the positive side. So my graph is going to be like this. That's how I can sketch the inverse of a function. Okay, then now on the same point, this is first situation. So let me go to second situation. Situation 2. You can actually sketch the graph without even having to find the equation of the inverse. We'll find the equation of the inverse later. Now let us just focus on sketching the graphs. So now second situation is when I take f of x is equals to the very same x squared, then where my x is less than 0, take all the x values that are negative. So it means this other part, this other side of the parabola. So since I took this other part of the parabola, so if I select x to be, I can choose -2 this side. Choose any point, -2. If it's -2, when you substitute here, it gives you 4. Doesn't mean you have to always choose -2. I'm just choosing -2. So it's going to be -4. Okay, and then now I have to find the inverse. I'm going to change this point. If I change at this point, if I reflect this point, it means I get -2 and 4. It means if you have a reflection about the y is equals to x, you have 4 and what? And -2. So basically 4 and -2, where is it? It's in this quadrant. Level. We have 4 and -2. It's in this quadrant. So it means the inverse will go like this. Level. The inverse will go like this, and then this is our line y. Our line y is equals to x. So this is now going to be the inverse of this graph. This is how we find the inverse of the graphs. So now basically it means now this is what we have, the inverse of the graphs. So this is my f, and this is the inverse. That's when we want to make this function, the inverse to become a what? So if you want to make the inverse to become a function, we restrict the domain. So I've restricted the domain of the function, and we found out the inverse is going to be a function. Okay, so now since we've done this, then we can also, now you know how to find the domain and how to find the range. Already we have the domain of the function, which is this one. So now what about, we can find the range, we can find everything. Okay, so I only did one example. Okay, so we'll do other examples. So for now, let us stop here, and then I will continue on the next video discussing how do we get the equation. So now we'll discuss, I will do another example, and also after doing another example, then we'll go and get the equations of different functions. How do we find the equation of the inverse and everything? Thank you.